complicated. I never know what I'm chasing, no. I don't need someone to save me, but you appear like a lightning bolt. Maybe you're a wizard, 'cause you're busy. There's magic in your rhythm, like a shockwave to my system. Maybe you're a wizard, 'cause you're busy. 'Cause every time I'm with you, you're my one and only elixir. Like a magnetic attraction, a supernatural vertigo. It's a chemical reaction, something I never imagined, no. Maybe you're a wizard, 'cause you're busy. There's magic in your rhythm, like a shockwave to my system. Maybe you're a wizard, 'cause you're busy. 'Cause every time I'm with you, you're my one and only elixir. You're the one that lights me up, ah. You're the one that lights me up, ah. You're the one that lights me up, ah. You're the one that lights me up, Baby, you're a wizard, 'cause you're busy. There's magic in your rhythm, like a shockwave to my system. Maybe you're a wizard, 'cause you're busy. 'Cause every time
Happy New Year.
Happy New Year.
How's it going, man?
Good. I've got a tool in my hand.
You are ready.
I've got my low center of gravity Traxxas chassis, and I'm moving the servo motor from my old car, from the high center of gravity chassis to the low center of gravity chassis. So just kind of moving my first couple of parts over.
Very cool. So no soldering is required, right? This is all basically screwdriver stuff. You don't have to solder anything.
No soldering. It's I hope not. I hope this is the way it goes on too. Yeah, you just kind of got this handy little tool set. It's kind of cool. It's got like a little quick release so you can pull and it comes with, it's a remote control car tool set. So it comes with all of the standard tools you need for all the hex bits and a Phillips head and a little socket that you need for working in a typical remote control car.
Very nice. We have to post a link for that. We're not getting any commissions from this. There's no advertisement for that tool, but
and there's a whole bunch. I can post a link to. Let's see here.
Yeah, that'd be cool. And welcome to. I see the captain has joined us already in the chat. Great to see you, Captain. Happy New Year to you as well. Very exciting. This is our first live stream of 2024. I just posted about this on LinkedIn a minute ago, but it's the first one to kick off the year. I think it's very fitting to have Eric do it. Not only because his live streams are awesome, but this is basically a nice continuation of a project we kind of were talking about right before our break. And that was pretty cool also. There you go. Eric just posted a link for that nice tool set. So did you mess around with this at all in the break, or are you coming in cold from 2023?
I'm coming in pretty cold.
All right, cool. That's the way it should be.
I had all these aspirations of doing a whole bunch of work on this over the break, but in the end, I just took a break, which is not a bad thing, right?
I think it's a great thing. I think it's a great thing.
Yeah. So let me set this down and let's just talk about what we're doing here today, right?
Yeah. So you were telling me before. So we're still covering the CAD to USD pipeline.
Yeah.
And using the specific F1Tenth model as the inspiration.
Absolutely. So let me share my screen. Here we go. So here I have Onshape open. Let's look at the whole car so far. I just, it doesn't have to be perfect. I'm making arms in a chassis that look halfway decent, but they don't really look like the real one. The appearance wise, they're not really that, they're quite a bit different.
Anyone who's jumping in for the first time that hasn't seen this before, so you modeled these pieces from scratch, right? This was not part of like a existing model set that was available.
Yeah. So, and what we're trying to do here is, if you take a look, let's just talk about F1Tenth real quick. What that is. The F1Tenth is Formula 1 10th scale, and F1Tenth is a race competition where they have these. Let's go to the build tab here. They take a Traxxas. Well, it doesn't have to be a Traxxas. They take a 1/10 scale remote control car, and they add a Jetson to it, and they add some sensors, and then they race them. And in this case, we're following along with their kind of standard build that they log here. It starts off with it's a Traxxas. If you can get one, there's a Ford Focus Rally Traxxas vehicle, and then they upgrade the motor to a brushless motor, and then they add some 3D printed parts to that. They add computers to it. They add sensors, and then they make a self-driving remote control car.
Very cool. And so, have you gone to one of these events?
I've not. No.
So how often are they held, and where are they held?
Man, I don't know. If you go to the race tab, let's take a look. There we go. October,
it's one in the fall.
2023.
Okay, so
it looks like the last one.
Yeah.
So I don't know what are coming up, but just looking at this,
Sounds like a good field trip could be coming up in 2024.
that'd be cool.
That'd be great. We could do a little live stream right from the right. So this is great. So all these events are all self-driving. People are not controlling them.
Yeah.
Very
You
cool.
use the cars to drive themselves.
That's amazing.
Yeah.
And what other technology are people using? You're obviously using a little bit of Isaac and Omniverse. What about people?
Well, we're kind of blazing trail here. They're training them in situ, so they're training them live in real life. And so and that's where this CAD comes into play, is we would like to train these cars in the virtual, inside of Omniverse, in the virtual world, instead of training them in the real world. Because for one, once you release the assets, you could do this for free. Wouldn't that be nice? If you just want to try to train a car, you can just do it in Omniverse. And but yeah, and you can train. Our theory or our conjecture is that you can train these vehicles, these autonomous mobile robots, much faster and much more efficiently, for a much lower cost inside of Isaac Sim than you could in the real world.
Yeah, that's awesome.
Yeah,
it's great. It's the way of the future.
We're setting out, and we're developing that workflow. And one of the first steps is to develop a digital asset that you can simulate as if it's the real asset. And so that means that all of the mechanical dimensions, so all of your suspension and your wheels, all those dimensions need to be pretty close, and all of your weights need to be close. It doesn't need to look the same, right? It could look like a cartoon for all we care. That's not always true. As long as it doesn't have to see itself, it doesn't have to look. The looks aren't important. But yeah, so we're developing this digital asset using CAD that will import into Omniverse, and so you can simulate this car. And on top of that, we're developing more of a pipeline. Now, a pipeline is more of I would call it like a data flow, right? And we're starting off with this CAD template. And if you have a different car, as long as it's got Ackerman steering and similar suspension, you could measure your car, input the dimensions into this template, and then you could just import your car directly into Omniverse without having to do so much CAD.
That's awesome. And you have a nice group talking about this on our Discord, right? And you have a Jet Racer channel.
Yeah. So we have a number of folks who are interested in this, and I would say a lot of them are interested in autonomous mobile robots in general, and just interesting, fun remote control car stuff. And it's not such a serious channel. we try to mix work with pleasure as much as we can, right? Talking about fun stuff and talking about serious stuff all together.
That's great. Well, I'm gonna post a link directly to that channel. So we invite to our Discord server right to the Jet Racer channel if anyone wants to check that out.
Cool.
I see Papa Chuck is here in the chat. Hey, Papa Chuck, Happy New Year. Data Juggler. I got the whole crew here. Janice Q. Wow, we got everybody here. Awesome. All right, let me look for that link.
And while you're doing that, I'll just start to go over this template a little bit. So what I've done here is I've started off with this. There's this suspension geometry tab. And what you see is this kind of just lines and points and circles, right, that mock up this kind of what the car looks like. And the way this is set up, I've got this parameter studio right here. And for each of these suspension hard points, you can take your car and you can put it into a corner. So if you have a flat floor and nice square walls, you can set it in that corner with the back in one of the corners, along one of the walls, the back and the left side, I believe. And then you can take a tape measure, however accurate you feel you need to be, You can take a tape measure, some calipers, and then you can measure the X, Y, and Z coordinates to these suspension axes and hard points, measure the diameter of the wheels, and there's this list of measurements you can take. And if you take those measurements and put them into this parameter studio, it will adjust this template to match your car. And then once you've done that, then the chassis is built off of that template, off of those dimensions. And so it might look a little goofy, but it'll more or less kind of morph to adapt to what you've done. And the same goes for these suspension arms so far that are loading. I had some uprights modeled, but I thought they looked really awful. So we'll remodel those later. I didn't like the way they were coming together.
So anyone can grab these work in progress models and fool around with them?
Not yet. I have to go through I have to figure out the release process through NVIDIA. So we don't, because there needs to be some kind of a license and kind of terms associated with it before I can.
I see.
Here's
he has a good question.
Is ISO 885? I do not know what ISO 8855 is. What is that one?
You let us know if you have a link for that, Sirens. We'll check it out.
I'm looking it up right now. Oh, I wouldn't say we're quite. So ISO 8855 is the road vehicles, vehicle dynamics, and road holding ability. Oh, interesting. I'll have to look into that specification and see what kind of a fit that would be. When it comes to the simulation in Omniverse, the joints and the mechanisms are simulated pretty well. So when it actually comes to the when it comes to like how those joints articulate, but when it comes to things like the wheel friction, that's not as accurate. And so for now, we'll have to see. So one question we have to explore is, well, how accurate do we need to be? And yeah, but looking at that ISO 8855, well, when it comes to the car axis, I'm not sure the way they orient in 8855. Let's see. Oh, here we go. Yes. Yeah. I did Z up and X forward. So that's good. Because if you look, here we go. Let me show you what he specifically is asking about is, and if you look at airplanes and, various vehicles, the axis systems, it can be all over the place. In fact, for aircraft dynamics, Z is down, if you can imagine that. And that's just because of how the aircraft dynamics work. You want to be able to, it has to do with the angles and the rotations. If you want pitch to be a positive angle, and then you kind of need to have Z be down because right now for a pitch of a car, if you look, a positive pitch angles the car down, and for an airplane that's pretty confusing. So so having a Z down axis system makes more sense for aircraft dynamics.
Very interesting.
So anyway, but that said, if you're doing structures for aircraft, then it's a Z up coordinate system, and in design, it's Z up. It's just in dynamics that it's Z down. Anyway, great question. Let's see here. Close that. Yeah, so this is F1Tenth, And we've got this modified Traxxas, and their typical build. There's two ways you can get there. One way is you buy this Ford Focus rally car from Traxxas, and you upgrade the motor. The other way is you buy a Traxxas Slash, and if you buy the Traxxas Slash, any of the brushless, they all come with brushless motors. I got them more basic brushless, and now I'm changing the chassis to a low CG chassis, so it matches the chassis of the Focus. I do wish, looking back, I wish there's an ultimate version of the Traxxas Slash that comes with an upgraded motor, and it comes with the low CG chassis, and it comes with aluminum A-arms and stuff. So it has a little bit different masses for the suspension, but I think I would have gotten that in retrospect. But here we are, making this chassis swap. No, not the end of the world. So, circling back around, I've got this CAD model, and the arm suspension is already measured off of Traxxas Slash. Let's see. Oh, but I did it a Traxxas Slash. I think I still had my high CG on it, so I'll need to probably remeasure once I've got the low CG chassis on there. But I still need to add the steering geometry to this template. Once that steering geometry is done, that's all of the mechanism is all modeled, and from there we just need to add weights to things.
Wow, so we're getting pretty far along here.
Yeah, we're in pretty good shape. And let's see, suspension arms. Okay, so now here's where it gets kind of fun. Here we have the full car, and you can see there are these revolute joints. 1, 2, 3, 4, 5, 6, 7, 8. So these arms are attached in CAD with revolute joints to the chassis, and setting up these joints in CAD is really a lot easier than setting them up in Omniverse. This is like a daily, or really a common task in CAD. And so really, if we can get our CAD directly into USD in a way that we can edit it and modify it in a consistent way, and then if we make changes to our CAD model, kind of update that part of the USD, but keep our changes that we've made, that would be a great pipeline. And today I'm going to show you how to do that.
All right. Everybody needs to buckle up.
So let's start by launching Isaac Sim. Give me just a moment.
We are starting Isaac Sim. Quick reminder that GTC registration page is up. There's a lot more information posted about GTC in the coming days, actually, with sessions and stuff. You can go to nvidia.com/GTC. I'll post a little link in the chat in a minute. I'll give you a little discount code, I think, on there. But that should be a lot of fun. Eric and I will be there. Let us know if anyone from the community is going. We'd love to hang out, meet up, introduce you to other folks on the team, help you with your projects. If you need help with Inception, if you're involved in a startup, those folks will be there, and we can introduce you there. It's a lot of great resources. GTC is just, if you can make it, well worth your time. If you can't make it, don't worry about it. We're going to do as much as we can virtually to support the community remotely. And here you go. Here's Isaac.
Yeah. So you can, in Isaac, out of the box, it comes with this import from Onshape button. And it just authenticated me. And here's our template, and we can import the full car. And great question. Any chance we see other supported CAD software in the future? Yeah, NX already has an export to Omniverse button. And Autodesk, I'm not sure all of them, but Autodesk, Inventor, and Fusion 360 can export USD files. And Autodesk Revit has a real-time connector, although that's architectural CAD, not engineering CAD. And if you go to File, Import, let's see if it has. I'm going to just show you this list of file formats that we support with direct import. You've got these are your 3D, kind of your media, like video game style, FBX and OBJ. But look, we got STL in here, CATIA V5 native files, NX native files, Parasolids, SolidWorks, STL Inventor files, CATIA V6, AutoCAD, Creo, Revit. Anyway, a whole plethora of CAD formats are already supported.
That's pretty awesome.
Yeah. One thing is they don't all bring in joints yet. That's why I'm using the Onshape connector, this Onshape importer, is because it supports joints. So I've hit so I've hit import here, and if I open up the full car, if I select the chassis here, and if I enable kinematic mode or kinematic enabled, what that'll do is it'll still simulate the mechanism, but the chassis will be kind of frozen in space. So if I hit run, there they are. We've got those joints from CAD. They've got collisions on even. We'll turn that off later because it'll cause problems. But that's actually one thing we need to do, right? Okay, so now we have this kind of raw import. It's got joints. It's really pretty far along. I'm really happy with it. But we need to be able to edit this. So we need to be able to add a collision exclusion group. We need to be able to change masses. We're going to have to be able to edit some of the joint properties. Once we get our shocks in there, we have to add spring and damping rates. There's a lot of, there's plenty of work we have to do in OpenUSD. But remember, as we go, we're going to need to re-import this CAD, right? And we don't have a connector yet. And so we can't just, it's a bit of a trouble. It's a bit of trouble there, right? Excuse me. This is where layers are our friend. So let me go ahead and save this. Oh.
By the way, the Isaac team has their live streams also kicking off starting next week. Alternating between the Isaac Sim team and Isaac Ross team. So it's every Wednesday. I'll post a link to our calendar in a second. If you got an Isaac question, it's a great place to ask the live streams.
I've got to connect to VPN, so pardon my
go ahead.
Stutter.
I can actually share my screen and go over a couple slides if you want while you're doing that.
Yeah, absolutely.
All right, let me see what we got here. All right, well, Eric's bringing that up. As I mentioned before, we've got GTC coming up, and it's going to go by quick. 2 months, a little over 2 months from now. Super exciting. Like I said, Eric and I will be there, so let us know if you're going. I posted a link in the chat already. A lot of people have been asking about DaVinci Workshop availability. It is now in the launcher. This is awesome. We had a live stream with one of the artists a couple of weeks ago, talking about his workflow and how he used Nuke, which we'll talk about in another second. Foundry's Nuke to polish off this awesome scene. But yeah, let us know what you think. It's in the launcher. As I mentioned a second ago, Foundry Nuke has been adding great support for USD. So check that out. If you have not fooled around with it, we have a great blog post. I'll post that in the chat. but we use that to actually finish off this really beautiful scene. And like I said, I'll post a link for that live stream where we talk to the artist and his workflow. We have still a few more weeks left in the Winter Art Challenge. It wraps up on January 31st. So let us know if you've got any kind of winter-themed art. Just use the hashtag Winter Art Challenge. Share it with the world. We would love to see it. It's very inspiring for us when we see the amazing work the community does, leveraging OpenUSD and your different DCCs. Really a lot of fun stuff shown off already. And as I just mentioned, the Isaac Sim office hours kick off again starting next Wednesday at 8 a.m. Pacific, alternating between Sim and Ross team. A great place to ask questions if you're working on a project or just diving into Isaac, or you've been in there for a while and just want to hang out and listen to some chat about the new features. And Aaron Luck's series is continuing to add new segments. The latest one was added a couple weeks ago, so check that out. It's on our YouTube channel. I'll post a link also in the chat. But it's great for newbies and veterans alike. Lots of great content covered here by Aaron. Yeah, I think that's it. Did your VPN connect okay?
Yeah. Let me bring this back now. Let me share my screen again. Or
I see it.
Oh,
sorry.
That's all right.
Did it at the same time.
Okay. We're just gonna do a sample edit to this scene, and we wanted to be able to. We wanted to apply to parts that are in this car, and we wanted to work in such a way that if we re-import this car, everything just kind of sticks, right? Everything reapplies. And so if you look, I'm right over here in the Layers tab, and I can create a sublayer. And what I can do with that, and let's call it Sim Ready. Oh, you know what? Is that create? Yeah. Sim Ready. No. All right. So now we've added this new layer, and when I first saw layers, I thought of them more as like folders, more like ways to organize and structure your work. Now I think of them more as macros. And the way that layers work is any changes we make in a layer, if we import that layer into a new scene, it'll make those same changes to those same prim paths in that other scene. So we'll set this as the authoring layer. And then we're going to come into the world here. And we'll go to create physics collision group. And let's edit this. Okay, we added self as a target. And then for the colliders, we say, I'll just filter here by colliders. Select. And that's it. So now, when we run the simulation, you see that the arms don't collide with each other. They filter each other out. Man, these are going to go for forever because there's no joint friction. Let's fix that real quick. Let's go into the stage. And by the way, we still have this layer active, right? And you can see that I've made this change and it's put these deltas onto these items in my tree. Let's do another one, okay? Let's filter by joints. Here we have all these revolute joints. Let's select all of them. And go to advanced. Let me see here. We want to just kind of add a little bit of friction. I'm trying to think of the best way to do that. Let's just look at one. Interesting. Joint friction. is right there. If I multi-select, will it still let me do that? No, that's okay. We'll just do it one by one, I guess. Let's just, we'll go to the joint friction here. Is that advanced? It was. It's like 0.1. Let's see how that looks. I think we want more than that. What is it? Oh, you know what? I don't know. I don't know if this is part of if we have an articulation set up yet. So we're just going through and kind of setting this up, right? Let's see here. I don't know if I do have an articulation. It's not there. What about right here? Here we go, articulation root. I'm going to delete it here. Well, let me think about that. Well, we'll keep it here for now. Okay, so we have an articulation root. That's fine. Let's go back and look at those joints. Go to this first one and look at getting it as friction. 0.1 didn't do much. Let's see if that does something. We're looking at this rear arm here. Let's make it really big just so we can tell what's going on. Should be like really. I don't think our articulation might not be working quite right. Let's see. With that kind of friction, it should not move at all, right? Yeah, that's not working. So let's reset that to 0, and let's see if we can fix this articulation problem. So I'm going to clear this filter. I notice that the full car has this articulation root. Let's remove it from there. And let's put it on the chassis. Create physics. I think it's add physics articulation root. There we go. So I've added an articulation root to the chassis. Where is it? There it is. Great. Oh, I might be able to just disable self-collisions for the whole articulation. We'll leave it with this filter, collision filter for now, but let's see if that worked. Because it was saying, I don't know if you saw this, that joint friction only applies for joints that are parts of an articulation. Oh, our friction is 0. So let's make it pretty big. And run it. Well, that's not working for me. Let's do this then instead. Oh, where are you? Let's reset that, and let's just set our damping. I'm struggling today. It does not go forever, you know. Well, Joint state.
Let us know if you have any suggestions in the chat. We can.
Yeah. Enable projection. I was there. Oh, sorry.
Sirens is asking if it's a physics scene.
Yeah. Just don't know why I'm not. It might have to do with my articulation setup, you know. But I did set this as an articulation. I wonder if it has to do with having this collision group on. Let's do that first. But then let's go to the articulation where it's had that. Let's disable collisions there.
Got a question or a comment from Captain here.
Oh, yeah.
I see Zia's back. Welcome back, Zia. It's awesome to see you. Happy New Year.
Well, there's the collision type. Let me see here. Do you mean this approximation? Let me see if I can show.
Yeah, he said yes.
Yeah, let me just show you. Okay. So just to follow along, I went to Window, Simulation, and I've popped up the Physics Authoring Toolbar, which has some really handy stuff. Where is it though? I thought there was a way. Here you go, Physics Inspector. And I believe now. Oh, no, this is this thing. There's a way to make the colliders visible. And I forget what that is now. Oh. Let me just actually Window, Physics, or Simulation, Debug. I know how to do it in here. Simulation, Debug, Visualization, and you can say collision shapes. Now if we run it, we'll see all of our collision shapes. And by the way, these are still colliding. So I guess I'm not sure what the unchecking that collisions thing does in the articulation route. But you can see our collision boxes. So now let's stop it. And if we go to this, well, let's pick this arm here. And here's the collider. And let's change it to SDF mesh is really nice. If you look at this one that I changed, you can see there's actually a mesh that wraps around the object. Whereas this one is just, you know, it fills in even this open area. If you did bounding boxes, like bounding cube, that's even less accurate. And it's particularly not accurate in our case because the bounding boxes are always aligned with the XYZ. And so if you bring some shape in that's on an angle, it'll make a pretty big bounding box around it. You can do like a triangle mesh. Actually, that's what we've got. That's on the outside. Here we go. Here's a convex decomposition, which wraps around it. But you can see it's got quite a few triangles. Convex hull, it's outside only. Bounding sphere doesn't make much sense. There's that bounding cube again. Mesh simplification, sphere approximation. What's that look like? Oh,
Wow. It's
That's
so
the new
cool
one.
to fool around with this stuff in real time.
Yeah, and then but if you're just going for convex decomposition, or excuse me, convex hull is really lightweight, but wraps it pretty well. I really like, if I need more accuracy, then I really like STF mesh. Although for the wheels, I'll probably use a bounding sphere because it does pretty well against the ground.
Yeah, Z was just asking about the wheels.
Yeah, so with the wheels, I did SDF mesh and it would go, but it's just kind of jittery and bumpy. And I couldn't make it. The problem is the collisions of these so far, what I've been able to model is rigid. And so where real world tires, they really dampen a lot of vibration and flex quite a bit. And so they don't really vibrate the vehicle that much. Here in Omniverse, they really do, because it's really hard shape. So for now, I'm doing those as spheres, and if you all keep in mind that really, as long as we're maintaining traction, training these models is just about the steering angle. It's like,
right,
if this AI can recognize where it's at, and if it knows it should steer right or left, that's going to be enough. If you want to train a car that can drift, so it's so it starts to like reverse steering and stuff depending on the situation and its speed and its angles. And well, yeah, okay, there you need. We're going
that would be wild.
Figure out some more, maybe a little bit better friction model.
We've got a shot in the dark here from Adam. Let me see. I'll put it on the screen. We all know Adam Hughes. He's watching. Hey, Adam.
Oh, hey. Oh, because they're instanced. Yeah, and I don't need them to be instanced, I don't think. Good. Let's try that.
Adam, you are welcome to join if you want. I'll shoot you a link to hop in here with us.
Yeah. Okay. No longer instanceable. Let's stop. Let's look at this joint. The chassis is the articulation root, and from the documentation I've read, you want the articulation root to essentially be the center of your robot. So I think the chassis makes a lot of sense. And then if you define an articulation root, what Omniverse does is any joints that are connected through a chain to that articulation root, it detects those automatically, and it uses this reduced coordinate, I believe it's called, this reduced coordinate solver. That's really a very accurate articulation solver, instead of the more video game standard solver. So we definitely want the articulation root set. Let's pick this joint here. Let's run this again. Yeah, we've got we've got them colliding. Let's see if the joint friction does something now. No. So I'll have to dig into that. But the real point here, let's see if something, let's say if there's something that we can see, right? Let's take each of these items, and instead of and if we go to their collider, let's make them all SDF mesh, just for kicks. So I made a change to these, right? Oh, interesting. And let's add that collision filter back in. So create physics collision group, filter it against itself, and then include all of our colliders so far. Great. So now it's going to be a little bit more stable. All right. So now we've done that. So if we go back to our layers here, and all those changes are on this simready.usd layer. So I can save this layer. So that's been saved right here. So now if I go to a new scene, I probably should have saved that. Oh, well. And I'm going to go ahead and import that again. Import from Onshape. This is where it gets cool. So if you look at this now, if I go to this chassis and that's full car. Oh, here you go. And if I turn on kinematics mode, if you look, okay, so this is a fresh import. And so it still has those convex hull approximations on each of those arms. But check this out. If we go to a layer, and if we insert an existing sublayer, insert this SimReady USD, now when we run this, you see that our changes have been applied.
USD for the win.
Yeah.
Very cool.
So inserting the sublayer. So all those edits we made throughout the tree, they're saved as deltas into this sublayer.
Very
so when
cool.
we import it into a new model, as long as it has the same tree structure, it'll apply all those edits throughout the tree structure that we made. And
What
so
if the tree structure was different? Would it give you, we throw an error?
No, it just kind of, well, let me show you.
Just wouldn't work.
Great question. If we do a file new, let's insert that sublayer here and see what happens. What it does is it adds just those deltas. So it kind of adds that tree structure to this empty one.
I see.
But if we look at any of these, like full car here, it doesn't have it doesn't have the full definition of full car. It only has whatever changes we have in that layer.
I see.
So like if we go to Revolute 1, it doesn't even show up as a Revolute joint. It just kind of has the deltas. So great question.
Data Juggler had a good question earlier. A little off topic, but I think it's a good question we probably all thought about. That's adding sounds. How would you add audio when collision happens?
I'll do that with an extension, I think.
Yeah.
Yeah. If you wanted to do that, you could listen. I'm sure you could listen to the collisions as they're happening in the physics loop, and then you could just use Python to play a sound, right?
That'd be cool.
Bueno, Nico. Hablo español. ¿Qué es esto? He said, what is that? I speak Spanish, so don't try to sneak Spanish stuff by me. I just speak the language.
Are you fluent?
Yeah.
You are really? Wow. I did not know that about you. You're a man of many talents.
I'm a little rusty. I lived in Argentina from 2020 till 2022.
Oh, wow.
So,
that's the best way to learn, right?
yeah. Yeah, definitely. Yeah. You get, if you've got to speak Spanish to eat,
Yeah, you'll
you
learn.
learn to speak Spanish pretty quick.
Let me see. Yeah, Azia's commenting that one of Ashley's demos uses audio.
Okay. I was in the Patagonia region while I was in Argentina, down south.
And then a follow-up from Data Juggler. What's a physics loop?
Oh, yeah. Great question. So let me think. So with any physics engine, you basically you basically run an infinite loop in your code on purpose. So that loop is just always running, and every time the loop runs, like let's say you're going to drop a ball just from the air, and your gravity was 9.8 meters per second squared. You started the ball at 100 feet up, and what you say is, I'm going to assume that you kind of come up with a time step. You say, we're going to say 1 millisecond passes for every loop. And so what you do is you after you say every time the loop runs, you say, well, a millisecond has passed, and you recalculate the position, the velocity, the acceleration of that sphere in your scene. And you say, well, it's moved by this much. And so you update all those numbers, and then you can query those and display the position of the ball on the screen and keep track of how fast it's moving, all of that. But yeah, absolutely. It's very similar. Zia says it's similar to a video game loop. And yeah, totally. Hand in hand, right?
Look who's here.
Hey, Adam. How's it going? Welcome.
How you doing, Mr. Hughes?
Oh, 1 second.
Okay.
How's it going, guys?
Yeah. It's such a nice setup. Happy New Year, man. How you doing? He's got the holiday lights in the back. Adam does not mess around with his setup.
He takes the interesting question. Oh, it moved on me. Is there a limit to the number of items in a collision group? Not that I'm aware of. I'm sure there's some limit, right? But
like the Tetris game that was just beat by the 13-year-old.
I saw that. Yeah, that kind of thing.
Who knew there was a limit?
Oh, Nico is just wondering what's going on. Oh yeah, no, I was just joking around, Nico. So
welcome.
Yeah, welcome to the party. And we are building a pipeline so that we can model a car in CAD, import it into Omniverse, and then have a car that's ready to simulate and drive around. So that's what we're working on.
By the way, I just asked Adam this a minute ago offline, but if any of you watching has experience with Rhino, we are working on a nice feature story on Rhino and OpenUSD, and looking for some users in the community to highlight. So if you've if that's you in some way, shape, or form, send me a DM on Discord. I'll put my info in the chat, or you can email me, edmar@nvidia.com. Adam, you must know some Rhino users.
I do. Do I want to volunteer them or not? You know,
it's okay. You can volunteer them. I won't tell them you told me.
Okay.
No, but that would be great. We're shooting for publishing that later this month. So get in touch with me right away if you are a Rhino user and you're leveraging OpenUSD. Very cool. So Adam, that's great. You were watching the stream and had some good ideas, observations.
I was enjoying it, actually. I was like, oh, I've never done this before, so maybe I should watch this. And so
it's pretty cool. I really want to check out one of these events, actually. These seems like be a lot of fun.
Yeah. I got a question from Joe. He's saying, could it handle 1,000 or 2,000 for a drone light show?
Ooh, that'd be fun. A virtual drone light show.
So a collision group lists things that actually where you ignore collisions. And so if you want things to collide, you just don't create a collision group. If you add colliders, then by default, they'll collide with each other. And 1,000 or 2,000 colliders, I I think, as far as I know, you can do that. Although if you're doing a drone light show, you might not even need colliders, and that would improve your performance. It depends. If you need them to collide, if you need to simulate that, then absolutely. But if you don't need to simulate it, you could just create the lights as rigid bodies and just not have colliders on them and just move them around without, and it just would ignore them completely as far as collisions go. Or it just wouldn't have that information.
Great question.
Yeah, interesting project. We'd love to hear more about it on Discord.
You know, probably does similar type of work. We chatted with this great team a few months ago, Moment Factory. Moment Factory does these really cool immersive events, real life events. But they also built a digital twin for their green room. They've got in their production facility, I think it's in Montreal. But they do light shows, leveraging, detecting where people are walking and things like that, and interacting with the environment. Really, really cool stuff. They do stuff all over the world. I think they've actually got something going on right now in Lake George, New York, if my Facebook feed is correct. Just the drone question reminded me of their work.
Yeah.
And you have 3 minutes. What can you do in 3 minutes, Eric?
This is going to show. Zia asked a great question. Zia asked, is there a way we can break this problem down to a smaller scale? And absolutely. In fact, and that's what this is right here. This is my simplified problem, simple articulation test model. And I've got this modeled in Onshape. I use it to test imports. I use it to test joints.
It's like a swing set.
Yeah. It's like a little, here's the ground. Let's kind of freeze the ground with kinematic enabled. So now if we run it, oh dear. So you can see we're getting some gnarly collisions and stuff going on by default. Because I've got the spherical joints and the colliders overlap because they're those convex holes. So even this simple one's got some issues we can fix. So anyway.
Dangerous swing set.
Yes.
You put a little test dummy in there.
There we go. Yeah, and so I'll probably use this to try to figure out what's going on with the joint friction. But I'll even delete some of the links. I don't know. Just really pare it down.
And then for a side note, there's been some improvements on importing CAD assets. I know that's what you started off with, right? Importing CAD.
Yeah.
There's like some real subtle things that have happened and trickled in. I think one of them is tessellation. Like there's a tessellation refinement. There's like a save location now. And then I want to say there's a BREP thing, but I'm not exactly sure if that's hit yet. But if not, you can apply boundary representations in Scene Optimizer now too, so that when you apply a material with the texture, you actually get the texture and not just some like default look and color, right? So usually CAD files don't have that boundary representation, that cubic or planar or triplanar mapping.
Mm-hmm.
And with Scene Optimizer, you can apply that now. So for those CAD people out there, those CAD folks, who want to make their models look pretty, new little bonus for you. Yeah.
Well, I tell you what, I think Omniverse is definitely the place to do that. But
yeah,
because you look in, I haven't seen the CAD softwares just are not as good at rendering nice looking materials as Omniverse is. That's for sure.
So is this true, Adam? Would colors from Onshape import now?
When you import from Onshape, file, import from Onshape, it does your materials.
I haven't done colors and I haven't done an import from Onshape in a while.
Let's just do let's just do a test here.
Okay.
Let's do a new scene. Let's open up Onshape. Oh dear. I'm losing track here.
I want to say yes, but I don't know if Kit's running the latest version or not.
If we go to the chassis, I have not applied a material on Onshape. Assign material. There we go. Let's just do
Is
like
the question
ABS.
material or colors or both?
Kind of both. I think it's just kind of. There we go. So now we've applied. This is now an ABS plastic chassis. Let's see if it picks it up. File, import from Onshape. There's the car. Yeah. So it already picks up that the chassis is ABS plastic because I applied that in CAD. Has a mass. There's some. Looks like there's tessellation properties I can do.
I want to see the colors come too. I just don't know how good the colors are. You know, like
Yeah, and
shaders
with this
like
ABS, I don't know.
CAD files don't use shaders per se, like the same way we would use shaders in Omniverse. Like they're just better, right? It's kind of like the default. It's like 32-bit color, right? It's not what it actually is. So I'm just equivalenting it to it. But
well, and it also didn't do an ABS look when I imported it. It just did the
uninstance it.
Yeah, it didn't still it didn't apply an actual ABS material to it. So that's something we could do. But remember, it's like if we use an edit layer to apply those materials, after that first import, they'll all just apply every time through that layer. So really cool.
So nice pop-in surprise guest from Adam there.
Yeah, that's fun. Thanks for joining us, Adam. Sorry, he probably had a meeting. He had
a meeting.
Well, that's it for this week. Just
that was
kind
a
of
good
showing
one.
you how to use those edit layers, and I think we'll be using those a lot as we move forward. Yeah.
Very cool. Great way to kick off 2024, Mr. Bowman.
Thanks. And thanks for joining us, everyone, and especially Edmar.
Yeah, of course. My pleasure. Great to see the community here. And thank you, Eric, for keeping this great project going. This is great. Remember, we got that Discord channel that Eric's managing, Jet Racer. Just go to discord.gg/NVIDIA Omniverse. I posted a link earlier in the chat, but there's a Jet Racer channel right in there if you want to continue this. But otherwise, next week, same time, right?
Yeah, and we're just going to keep making this sim-ready CAD model so that we can we'll work on the CAD and we'll work on that edit layer so that you can just import this template and have a sim-ready remote control car ready to go.
Very cool. Exciting stuff. All right. Thanks, everybody. Thanks, Eric.
All right. We'll talk to you later. See you next time.